and go. Okay, so we're going to start with example 2. Now everybody's got their calculator out. We're going to put in square root x minus 2. Now it opens that bracket for you. Now some actually people with the 84s, they have the updated software, and it actually it keeps extending that like line over top, right? So it actually shows that all of that is underneath. Remember, if I don't want the negative 2 or the minus 2 underneath, I would shut the bracket after the x, because they're very different graphs. Okay, square root x minus 2 and square root x minus 2, very different graphs. Okay, and we're going to learn that more next year when we get to all the transformation stuff. So let's all hit zoom 6, so we're all looking at the same graph. Okay, so what I want you to do is just right click on this, take a screenshot, and draw it. So time consuming. Okay, so just going to put this here. Oh, it's fair. It may not be equal, but it's fair. Okay, so just from this, what would be, I just want you to put up your hand, okay? What would be the domain of this graph? What's the domain of this graph? In other words, what x's are being shown on this graph? Okay, putting up your hand. Yep. Okay, it's actually x is greater or equal to 2. And then, x in the reals. See, why does x have to be greater or equal to 2? I see that on the graph. Let's look back on the formula here of square root. What if x was 1? What would happen? Why can't x be 1? It'd be a negative underneath the radical sign. If it's 1 minus 2 is negative 1. You can't take the square root of negative 1. So there is restrictions on this. And restrictions mean only these numbers can play. Okay? The rest of you can't. So every one of these radicals, we're going to have to come up with restrictions. But I wanted you to see the visual of it. If you look on here, and there's no arrow on our calculators, but it's going that way. Everything gets to go as long as it's greater or equal to 2. Now the reason why it can be equal to 2, because you can't take the square root of 0. It is 0. Because 0 is not considered a negative number here. Okay, so even if you look in here, we should be able to say, yeah, x has to be greater or equal to 2. Okay, now how do you solve this algebraically? Well, this is what we're trying to say. We're saying that x minus 2, that entire thing has to be positive, correct? Another word for saying positive is this. This means the same thing as positive. I've had students in the past go, what does x greater or equal to 0 mean? I go, it means it has to be positive. Because that is every number in the world that's positive. So then I just do a little bit of algebra. X has to be greater or equal to 2. So even doing the algebra. But this is the step that says the truth. Okay, that has to be positive. Therefore, I'm going to solve for what is positive. Okay, does this make sense? By looking at the graph, by looking at it even common sense, and then by doing it algebraically, we come up with the same conclusion all 3 times. Okay? So this is meant to be redundant because it kind of has to make sense, not just plug it into the formula. Now, all of these, we wanted to determine the restrictions. Did not ask me to solve them. Be very careful with that. It said, what numbers are allowed in here? Didn't ask me to solve for it. Because I would solve for this very different than I would find restrictions. So we're going to do, just so you know, we'll do A, C, and D. and we'll come up with what is allowed. So, once again, did not ask me to solve it. So don't jump right in there and solve it, because if this was multiple choice, I'd have that waiting for you. You spent time on it, you probably did it right, probably demonstrated some good math, you're getting it wrong. Okay? So, to show the restrictions, I could graph it, or I would just do, well, 4x plus 1 has to be greater or equal to 0. That's my restrictions. Then I would go and solve it. So I'm going to minus 1, minus 1. 4x has to be greater or equal to minus 1. Then I would divide by 4, divide by 4. What would happen if that was a negative 4x? I had to divide both sides by negative 4. No. Oh, it would turn on positive on the other side. But whenever you divide in that last step, if you ever divide by a negative, anyone remember the rule? You have to reverse the sign. Okay? And the reason being, okay, like, is this a true statement? Actually, I want to do this, okay? You don't have to write this. I just want you to watch. Is this a true statement? Okay? Now, I'm going to divide both sides by 2. So that is 3 is greater than 1. Is that a true statement? And if you divide by any single number in the world, except a negative, it remains true. But I want to try this one. I'll show you. 6 is greater than 2. What if I divide by negative 2? Is negative 3 greater than negative 1? No. So this you have to say. So whenever you divide by a negative, you got to change the sign, because it's untrue if you don't. So that's a little tip when you're doing these. Make sure in the very last step, when it's something x equals something, if it's a negative x and you're dividing both sides, you're going to have to reverse the sign. Okay? Again, write that on a study sheet in 3 months when you're studying for your final. Bang, that comes back to you as soon as you read it. Otherwise, it's embedded in this textbook that's about that thick, and you probably will never find it again, and you'll probably do it wrong on your test, okay? Okay, the next one is kind of weird because I have 2 different radicals. So I have to solve for both of them. So for this to be able to work, well, x minus 2 has to be greater or equal to 0, right? So all we have to do is add 2 to both sides. X has to be greater or equal to 2. Got that one done. And x minus 4 has to be greater or equal to 0. So x has to be greater or equal to 4. Now, use common sense here. What do you think the answer is? 2? Okay. So what happens if I put a 2 in here? Is this equation solvable? Has to be 4. If I put 4 into both of these, are we good to go? Yes. So my answer would be x has to be greater or equal to 4. So here's how I do it, I think in my mind, in a number line. Here's 2. Here's 4. So the first one was saying this. X has to be greater or equal to 2. The other one is saying x has to be greater or equal to 4. Take the one that is more right, as in not correct, but more right. Now, if they were both pointing left, I would take the one that is more left. Okay, and it always works. Now, what about the ones that shoot off both ways or shoot in both ways? Okay, so let's talk about that. That's D. So the number line, I think, helps illustrate. If they're both pointing right, you got to take the one that's more right because, hey, where's my highlighter? There you are. This does not work for that second equation. Okay. Now, nothing on the left side of 2 works for either equation. This part does not work for the second equation. Therefore, all of it's bad. Okay. You can say, well, I can solve the first part, but the first part with an answer minus no answer, still not going to help me. Okay. I think the number line kind of pictorially shows what's going on. Okay, this one, I need x plus 2 greater equal to 0, and I need 3 minus x greater equal to 0. Okay, so the other one, or the first one I should say, so x has to be greater or equal to negative 2. And, okay, like in this one, it's a good thing I picked this one, because this one's going to show me what I was just talking, or show you what I was just talking about. So first of all, I will get negative x has to be greater or equal to negative 3. I just subtracted 3 to both sides. What do I have to do to make that positive x? I need to divide by negative 1. Little alarm, little flag, something should be going off right now saying, whenever I divide by a negative, reverse the signs. So x has to be less than or equal to 3. Okay, now the number line is going to help us see what's going on here. So if I draw my number line, I don't have to get fancy, but I have x has to be greater than negative 2. So negative 2 is over here, has to be less than 3. Okay, so this one's pointing this way. This one's pointing this way. Do you see how, getting my highlighter out, this is bad for the one of them, and this is bad for the other one. So that will not work for either one. I'm going to write bad on top of these. I think you guys will know what that means. So the golden stuff, the only stuff that works is the stuff in between negative 2 and 3. So that's how we write x has to be greater or equal to negative 2 and less than or equal to 3. Now, does everyone know how to read these? It's always you read from the inside out. I'm going to write these below. So you write, it reads x is greater than negative 2, x is less than negative 3. You read from the inside out. That's what that means. Now, if you really wanted to, you could just put x is greater. You can separate it. But you got to get used to this because this is how it's going to be done for the rest of your life. Yes? Doesn't matter whatsoever for this. Correct. Because I just need to know what would make this radical not even work. Now, if I was solving, I'm not going to, I'd have to do this and solve it. Okay? Because solving is finding x. This one is just finding when x is bad. Or when x is good. Okay? Okay, let's do some graphing. Okay, so kind of, now we are going to solve, but we're going to use the calculator. So, do you know how we would, yesterday we brought the 4 to the other side, x minus 4, root x plus 1 minus 4 equals 0. You can do that. There's 2 ways to do these. Yesterday's way, where we bring it all on the left, make it equal 0, and find x-intercepts. Or, you could just do left and right. So what is on, I'm just going to move this here for a sec, what's on our left? Let's turn it on. Let's do the square root x plus 1. And what is on the right side is my y2. That's 4. Hit graph. First one comes up. Second one comes up. Okay. Now, have they hit each other? No. So the answer is where they intersect. So how am I going to find the answer? Actually, that sort of turns into a wild goose chase sometimes because when you zoom out, it makes this. But really, do I need all that other stuff on the left side of like this stuff here? Is it going to come over here? It's over here somewhere. So which of these window settings should I be changing? X max. So I could change it to 20. Now, I never go, okay, put in this, or whatever. Because students are like, how does he know that? How does he know that? You know how I know that? If I was to do that? It's because I did this. You just keep trying. So we're always going to do it together where we're trying. Because I never want you to get the idea that you should just know how to put your window settings in as soon as you do this thing. Okay? I'm like, hey, it's not intersecting yet. So I'm going to move over a bit right. So I put my 20 in. I did get where it intersected. If I would have put 15 in, 12 in, wouldn't have done it. I would have had to keep going. So it's almost bad that we got it the first try because you'll think we'll get it the first try all the time. You don't. You know what I usually do? I hit Y max and I'm like, oh crap, I didn't do anything. Okay, it was X I was supposed to do. Okay, that's the reality of this. It's trial and error. It's playing around with it. Okay, so again, just take a screenshot. Draw it on this graph here. Okay, so just so you know, that's our answer. How are we going to find that answer? How are we going to find that answer? Intersect. Second, trace. 5. Enter, enter, enter. 15, 4. Okay, so let's write that down. This is 15, and obviously that's 4 because that was y equals 4 I put in. So, state the solution. X equals 15. Verify it algebraically. Square root 15 plus 1 supposed to equal 4. Square root 16 supposed to equal 4. Square root 16 is 4 equals 4. It works. Anyone know by looking at this what the restrictions would be? It's pretty easy, right? If I had to do it, x plus 1 has to be greater or equal to 0. X has to be greater or equal to negative 1. That's how fast you can do it. Okay? That's restrictions. Is 4 matching my restriction? Or sorry, is 15 matching my restriction? Is 15 greater than or equal to negative 1? So you got to check that sometimes. It shouldn't have verified if it wasn't following that rule anyway. Okay? Still got a couple people writing, so I'm not going to go to the next page yet. Just let it sink in. Now, the next thing we're going to do is we're going to learn how to solve these algebraically. Now, you know how to check them on your calculator. So, none of you have any excuses for getting any wrong on this test. Unless you're struggling through it, you do not have time, and you don't even have a chance to check it over. But you can see on the last test, a lot of people finished like with 45 minutes. Now, 45 minutes is a lot of time to check everyone, find your mistakes. Okay? So, now, this one here, how do you solve these algebraically? Well, first thing you do is you square both sides. That's how you get rid of a square root. So, x plus 1 equals 16. Oops. Then I'm going to minus 1. X equals 15. It's almost faster to do it than with the calculator. Okay. Let's do a little bit more Now here's a 3 plus root x minus 1 equals x. Now the first thing you need to do is you need to isolate the radical term. Now that means get it alone. I'd like to get it alone the side it's on. Okay, it's less work. So the first thing we're going to do is let's minus 3 to both sides so I can get it on its own. Then I square both sides. So you square both sides. This will be x minus 1 equals x squared minus 6x plus 9. They had to FOIL it, right? So it's going to be x squared minus 3x plus 9. Yeah, if you, this, so what's ever in here just gets released. So what, this would equal cow. It's like letting the cow out of the fence. It's amazing how this mind thinks. Eh? It's almost scary. Okay, so let's solve the equation. We're going to bring this minus x to this side, and I'm going to add 1 to both sides, okay? That gets rid of everything on the left, leaving me with an equation. Now, could I put this in the calculator and solve? Yep. But you could have put it right from the beginning and solved it, save yourself some time. This one wants it all algebraically. So then I'm looking for two things that add to negative 7, multiply to negative or to positive 10. Negative 5, negative 2. So I got x minus 5, x minus 2. I have it so it just rings once. Or else people just annoy me. I got a voicemail. Okay. So what are my x's? 5 and 2. Okay, now here is the part that textbooks always say that solve and verify, right? When you do these. Now, how many people really verify? They get their answer and they're like, "Ooh, yeah, on to the next one, on to the next one, on to the next one," right? Well, you will get crushed on these if you don't do this step. I wouldn't, if I were you, if I wasn't going to verify, I wouldn't have done the other steps. Save yourself some time to skip the question, because then you can work on something else. You're getting this one wrong because you're not verifying it. So you might as well not even do it. Take time on the other questions, okay? And I promise you, you don't verify these, they'll be a little multiple choice ready for you to pick. And you'll pick 5 and 2, because we don't know if one of them could work, both of them can work, or none of them can work. Now, in the past, you always said, hey, I got an answer. Obviously, it's got to work. Well, when you deal with radicals, the rules change. Okay, so let's do 5. Let's just check it. I have 3 plus, so we're going to check 5. Okay, so let's do x equals 5. 3 plus root 5 minus 1. That is supposed to equal 5 minus 3. Right? I'm just putting 5 in for x to the original. All right, yeah, just 5. Okay, good. Then it is 3 plus root 4 equals 5. 3 plus 2 equals 5. 5 equals 5. Okay, that's good to go. So let's do x equals 2. It's supposed to be 3 plus square root 2 minus 1. It's supposed to equal 5. 2. Okay. 3 plus the square root of 1 is supposed to equal 2. 3 plus 1 is supposed to equal 2. 4 equals 2. What do you mean 3 plus minus 1? What? I didn't take, if I take the square root of both sides, I have to do that. The square root was already in there. Okay? When you have, if this is your question, square root x equals 2, the answer is, or the answer is 4. It just is 4. Okay? But if I was given this, x squared equals 4, and I take the square root of both sides, as an algebraic move, x would equal plus or minus 2. And that works because negative 2 squared equals 4 and 2 squared equals 4. Because the square root of 1 is 1, not negative 1. Okay? There's only one answer when you do it. Okay? I know what you're saying. It's right, but the way you're thinking, it's just the rule. Okay? So, could 1 be? Yes, it could be, but it's never going to be that answer as a rule. Okay? So I'm stressing you're not thinking wrong. It's just kind of a rule. Okay? It's an awesome question. It's always going to be positive. But if you take the square root of both sides as a step, it's positive plus and minus. Okay? And that's why these screw up a little bit. Okay? So, and if you did the restrictions, actually, well, this one wouldn't work out even for the restrictions, but you'll see that this is not a solution. So we're going to say no. So your real answer is x equals 5. So here's a typical multiple choice question. You guys might need this, so you should pay attention. Okay. It'll say x equals 5, x equals 2, x equals 5 and 2, no solution. There would be my, and I'll get a lot of people picking 5 and 2. Okay, test them. This is called, when it's not a solution, this is called an extraneous root. Okay, so if you go to the next page quick, we talk about extraneous roots. And they are solutions you will get that do not apply when you check it. Now, if you know much about court or whatever, you'll hear this in court a lot. Now, if you had this murderer in there, okay, and the lawyer's trying to paint a really bad picture of this murderer, the lawyer could say, and he's really mean to his mom. Now, that has nothing to do with the case. The other lawyer will go, that's extraneous, stricken from the record. And all of the jury has to put that out, because it is extraneous, has nothing to do with the murder. But most lawyers will still say that, because people are human beings. They won't go, letting that go. Most people go, he's mean to his mom? What? I don't like it. What a jerk. I hope he goes down, man. Right? So don't think lawyers are like dumb by putting this in, but they will put in information that's extraneous. And when the jury meets, they're not supposed to bring this up. They can't go, and he was mean to his mom. No, that was not allowed. Remember, we're not to talk about that to get a verdict. So extraneous is information that actually we got. It may be true, but you're not allowed to use it in this case because it doesn't prove he's a murderer. Okay, so that's what extraneous information is. That's what an extraneous root is. It's an answer you actually get, but when you test it, because of the algebra you did, it's wrong. Okay? So here will always be your steps. Isolate the radical. So you got to get that radical alone. Then you need to square both sides of the equation. So anyway, get radical alone, right? That's what that means. Square both sides. Okay. Now, if you still have another radical, you've got to isolate it again, then square both sides. Then after you get your answer, verify and solve for extraneous roots. Now, come on, you even have to admit, if you were making an exam, you would want one of the answers to be extraneous. So you're seeing if they're checking them. Okay. Sometimes both could be extraneous. Watch out for that. Sometimes none of them. You have to test them. Okay. So yes, there is a lot of accountability here. Okay, so this one here, are the radicals isolated? For this one, let's do B for this one. So if they're isolated, so let's just square both sides. And these turn out to be pretty nice after you do that. There's no boiling or anything. But squaring things sometimes makes things untrue. Okay? And see, if you had this statement, would you agree with this statement? Well, I'm going to square both sides because in algebra I'm allowed. I'll do it to one side, do it the other. I'll square this side and then I'll square this side. It's all good. Next one, does this equal this? Okay, actually, or no, I should say this right now. Does this equal this? Well, I'll square both sides because in algebra I'm allowed. So, sometimes squaring makes things true, yet originally they were not. Okay? Yes? If you put this into your calculator, you will get this answer. You always have to put it in brackets. Because I'm asking you to square negative. Do you know what? This is not squaring negative 2. That means negative. This is what your calculator thinks. Okay? That's exactly what your calculator is thinking when you're doing that. But I asked you to square negative 2. Not do a negative to a 2 squared. Okay? So you always have to substitute in brackets. If you don't, you're always going to get these wrong. Okay? So back to where I was going, because I squared both sides. Sometimes it's going to go and make something untrue true. Okay? And then we're going to verify it and go, what? It didn't work? Well, that's because it was never true in the first place. Okay? So let's finish this off. I can subtract 3x to both sides. That's a negative 2x. And then I'm going to add 3 to both sides. Equals negative 2. Then I'm going to divide by negative 2. Now, there's no inequality sign. You can reverse your equal sign if you want. I think somebody got it. Thanks. Okay, so 1x equals 1. Now, is it correct? Let's see. Does the square root of 1 minus 3 equal the square root of 3 times 1 minus 5? I got the square root of negative 2 over here, and this is the square root of negative 2. Yeah, so there is no solution. You cannot have square root of a negative 2. So that squaring actually made it possible to do. And then after, just like negative 2 didn't equal 2. I squared both sides. Suddenly I'm good to go. Well, that's where you're going to run into problems sometimes, okay? So you always have to verify. Okay. Let's just do this one. This would be considered a gooder to give on a quiz, right? You got to know your stuff to do this one. And it's bad enough you can't even use your calculator. Okay, so the thing is you got to isolate one radical. So to do that, I am going to minus root x to both sides, because at least I have one radical isolated. You can only do one at a time. So then I will square both sides. Now be careful. I might be making something true that was untrue. Maybe that whole left side. See, if you come back here, I just actually want to, there is no way those two, if you graph them, they're two different graphs and they never intersect. Okay? That left side will never equal that right side. You won't be able to find me a number that works. So it was untrue in the first place. I squared it and I got one. I got one. So yay, I got an answer. Okay? But because I squared it, I made something that was never supposed to be true, true. Just like negative 2 doesn't equal 2. Square both sides. It is equal. So negative 2 does equal 2. You're going to be like, what? Grade 1, they even taught us that's not true. Okay? So someone can't convince you by squaring it that those two are equal. Yep. Yep. Yeah, you can. I said that. I've said that a million times. Where it's going to mess you up is the written response. Right? But you did all the work. Or maybe you did that first. You did the work to keep making sure it's going to look like that. Bang, got it. Okay? So is it going to be a tool to help you make sure you got it right? Yeah. And I think that it would be unwise to not use it. You know, you got a diploma coming up. I'm going to show you lots of ways to be able to check your answers in the diploma. I mean, the students are getting hundreds in the diploma because they know how to find their mistakes. Yep. Yeah, well, you'll know. Like one can go like this, and the other just goes across. Well, they hit each other. That's awesome. But one's going like, you know, starting here and going like this. The other one's starting here, going like this. They're not meeting. Yep. And they might intersect twice. So, right. That's where two solutions will work. So you can have 0, 1, or 2 solutions. 0 would be never meeting. You got 1, and then maybe 1 does, you know, like this, and they meet twice. Okay. So that would be the visual of the answers. Okay, let's square this side. This would be x minus 3 equals. Okay, remember what this means. I'm even going to write this out because this still works with our radicals. That's why I did the radical. That's why the radical unit's first. I mean, it obviously is. So that's 5 times 5 is 25. Then I've got minus 5 root x. Then I've got minus 5 root x. And then what's negative root x times negative root x? It's just x. So I got x minus 3 equals 25 minus 10 root x plus x. What do I do next? Isolate the radical. Okay, so we can leave it on the left. We can, if I put it to the right, it becomes positive. So I'm going to kind of do that. So if I bring that to the right, that would be positive 10 root x, right? If I minus, or add, sorry, 10 root x here. And then to get everything on the other side, I'm going to minus x. What happens there? That's pretty nice. And I will add 3. Add 3. So that will give me 28. So something pretty darn messy. I like that. Kind of tidied up. Now, there's 2 options here. You can square both sides at this point, but I wouldn't yet because I can do something still. I can divide by better than 2. I can actually divide by 10. So I'd have root x equals 28 over 10, which is actually root x equals 14 over 5. I'm just reducing my fraction. Don't put a decimal there, but you can leave that as a fraction. Now, I'm going to square both sides. Now, when you square a fraction, it's 14 times 14 over 5 times 5, which is 196 over 25. So your calculator is probably not going to give you that one nice. It's going to give you some random decimal. But 196 over 25, put it in, get the same decimal. Life's good. I know I got it right. Okay? Now, is it a solution? Now, if I saw them intersect on my graph at that point, I cannot just write, yes, I graphed it, and it is a solution. That is not. So you can see you will get a mark for this thing. Okay, so all you're going to do is put it in. Square root 196 over 25 plus square root 196 over 25 minus 3. Does this equal 5? Now, what is square root of 196 over 25? We know that already. It should be 14 over 5. Because remember, I squared it to get that. Plus. Now, we've got to make this. 3 has to subtract to that. So, instead of 3, I'm going to put something else to subtract. You have to make a common denominator. So what do you put? What is the same thing as 3, but as a common denominator? 15 over 5? Well, we don't want 15 over 5, though. I need to have this thing over 25, right? 75. Negative 75 over 25 is the same thing as 3. So what is 196 minus 75? Anyone know? 121. That might ring a bell with some people. Okay, so that, I'm going to actually take this as a number. This would be 121 over 25. What is the square root of 121 over? 14 over 5 plus what? 11 over 5. This is supposed to all equal 5. I don't know if you still remember that. Remember we were trying to do that? What is 14 over 5 plus 11 over 5? Oh, this is looking good. 5 equals 5. Therefore, I would say 196 over 25 is a solution. Yes? Yep. Okay. Brain hurt a little bit? Good. Thank me later. So let's do 1 to 8, but you're going to omit 7. AKA 1 to 6, comma 8. Just remember, don't get find the restrictions mixed up with find the solution. And